All right, hey guys. Hey, I want to go over this circuits practice problem. This is from the 2014 AP Physics 2 exam. It's going through a little bit of internal resistance as well as just understanding some of the basic circuitry components and resistors that are ohmic. So not too difficult of a problem, but they definitely try to trip it up a little bit with this graph that they give us here. So not a very typical graph that we're going to get in terms of circuits, which is the inverse of current and resistance, um, and looking at that relationship there. So obviously we have a battery with internal resistance, and the main thing they want us to do for the first part is just write an equation that relates all those different values of equal resistance of the resistor, internal resistance, current, and electromotive force, right? Or essentially the voltage of the battery. Okay. Second part then has us use that equation to determine the EMF as well as the internal resistance. So there's kind of two ways that you can go about doing this, right? So I use these 2 points here. Point one here, it kind of crosses right in the middle there. I said that's 27.5 for my resistance, and then 0.5 for my inverse current. And then point two was here with 45 for my resistance, and then 0.8 for my inverse current. All right, so the two ways you can go about doing it is one is using that equation and having it relate to the graph that we made. So if we solve for it in terms of y equals mx plus b, my y value needs to be my inverse current, my x value needs to be my r. So to do that, what I would do is divide each side by the current, and then I get EMF over I equals R plus R. If I then divide each side by the EMF, I can get 1 over I, which is my Y value here, equals R over EMF plus little r over EMF, right? And so you can kind of see how those relates to our equation Y equals mx plus b, right? Slope is 1 over my EMF. R is my X value. So I kind of split R over EMF into R times 1 over EMF, plus B, which is my little r over EMF, okay? What I could do then is I can then find my slope, just as my slope formula. I use those points that I showed before. And then from that, I got an EMF of 58.3 volts, right? B then, my y-intercept is how I can figure out my internal resistance. What I did is I just took, this is my EMF, I plugged it back in, and then I took 0.2, I think, and plugged in and solved for my internal resistance of 1.64 ohms. Okay, so that's one way you can do it. Second way you can do it is without trying to figure out the slope of that graph, is we can just take this equation and plug in 2 points. So I have those same points here. Both of them, I don't know my internal resistance or my EMF, but I know my big resistance and I know my current, and I did this by calculating the 1 over the value that's from, so 1 over 0.5 is 2 and 1 over 0.8 is 1.25. Set those two equations equal to each other because they both equal E, and then I can work through this and I can solve for little r. I got 1.67, hey, that's really close to my 1.64, so I'm pretty happy with that. Then plug that back in to my equation, and I got a voltage of 58.3 volts. So pretty happy with that. All right. Second part then, it asks for if we had an unknown resistor X, how would we want to prove, or how would we want to set it up to see if it's ohmic or not? And so what we basically want to do is we want to run a number of different currents through that resistor and measure the voltage. So how we're going to do that is we can just do a simple series setup. R, we're going to change. We're going to measure the voltage just across this resistor here, see what that voltage is there. And then because it is a series circuit, no matter what, it really doesn't matter where I put my amp meter, because that current is going to be the same always through X, okay? What I can do then is kind of just explain, swap out different values of R. That's going to determine a different current for each time. With that then, I'll get a different voltage here across resistor X, and I can then find the difference, or V over I, and see if it is ohmic. All right, so I'm trying to see, does that value of R, does that ratio of V over R, or V over I, excuse me, voltage over current, always equal the same value? If it is, then that is ohmic, right? And that kind of takes us into part 3. I would basically graph V over I. I should get a slope or a line here to represent R. The slope of that line is my resistance. What I'm looking for is I'm looking for a linear relationship where that line is a straight line. That's going to show that that slope doesn't change, and that resistance value does not change either. So that's going to show that it is an ohmic resistor. Part C then asks, how would things be different if the internal resistance of the battery was not ohmic itself, but would actually change? Well, if we have this setup, it really wouldn't matter, because what we were already doing was we were already changing big R, which was changing the current. This little r would change the current as well, but then if it is ohmic, my voltage should change correspondingly to that, right? So I said, no, if current changes due to changing resistance of little r, the voltage across X would adjust appropriately and still show if it is ohmic or not, right? So hope that helps. Let me know if you have any questions, but that is a quick breakdown of the circuits problem from 2014.